Welcome back, everybody. My name's Danny. This is an NSX 4.0 tutorial. If you're new to this channel, this is a NSX 4.0 series of episodes. I've been giving you a lot of topics about NSX 4.0, including design components and switching and routing. So if you're new to this channel, please search for the existing videos for the fundamental, the NSX. In today's lesson, I'm gonna cover NSX design. So NSX design is a pretty critical topic, or a little bit complicated topic for you guys, because this is a require a point or just require section for the NSX system. So let's get started. So in today's lesson, we're going to talk about design NSX, and if you just going to talk about a lot of the important factors about design, like steps or some of the theories. But if you want very detailed information about design, you can just go over to the design guide, reference design guide. I think this is the latest one for NSX version 3.2. It is released in February this year. So this is a very thorough and complete reference design guide for you to refer to. So for example, the section 7, where today we're gonna talk about those topics right here. So we're gonna emphasize the compute cluster design, and so focus on the edge node and services design, especially edge node design, or so just a whole bunch of information and detail will be shown in this diagram, in this guide. So just give you a URL link in the comments below, so you can take your time to look at it. So speaking of design step, there's a question for an enterprise. They wanted to have an NSX POC or have a NSX deployment. There are 5 new physical servers and some switching connection for you. So you need to give them a design proposal for this POC or just a real deployment. So what would you do to start this POC? So the purpose for this topic, for this session, will be how to design an NSX for your whole system and in the enterprise. So we're gonna talk about physical topology. So there are 5 machines right here. So we have to break it into 2 parts. One part is a compute cluster. So you need to create a compute cluster for including the 3 ESSI hosts in vCenter. You also need to create another cluster named management or just edge node cluster for you to locate your edge node, NSX edge node. So in the future, edge nodes will be setting in on these two machines. So that's the physical topology, and also you have to have some of the vmware physical network adapters, and you're gonna have an NSX manager installation. So for a POC, I think one manager is enough for you. It really depends on you POC testing items, or if you're having the real deployment, you have to have install 3 managers to become a cluster. So what's more is for physical topology, we have to think about how to connect to the external world. So here's external routers. Commonly, you have 2 external routers for HA redundancy, and absolutely for sure you have to have your vCenter and some of the operation machine, or like jump box or sort of things are. That's it for the physical topology. And here's logical topology, which is very important. So when you finish your design, you have to negotiate this, discuss the logical topology with the enterprise network team. So because there's a lot of cooperation between the NSX world and the external physical world. So let's talk about this diagram from bottom and upwards to top. Here, no matter if you have a deployment, real deployment, or you're conducting a POC, you have some of the production machine here. This is a production VM or simulated virtual machines here. So you have to plan on those machines. Here we have a web segment, we have a app segment, and an app segment, and also have a DB segment. Depends on depending on you real requirements and the customer requests, you can have one T1 gateway or more than one T1 gateway. If you want to have if you have multiple tenants to to consider, and you're gonna have a T1 T0 gateway for north-south traffic, and also vCenter and some NSX manager. So here for uplink, you can see there's 4 subnets. Seems like we have 4 subnets. We also need 4 interface on the physical router or external routers. But I think you should, to be accurate, I give you another diagram. So for T0, remember we talked about T0's HA mode. We have AA mode. We have a AS mode for T0 deployment. Generally speaking, or commonly used, we use 2 tier 0 T0 routers, and here's external 1, external 2. So we're gonna show you the connection here. So for T0, from the HA perspective, we have this IP, we have this IP on the same subnet, and goes to this interface. We also have another one on another segment or subnet or uplink just right here. So now we have two subnets with 3 IP address or 3 interfaces each. So when we ask for the IP address on for the external router, we just request 2 interfaces, one for each external router, and for T0 side we have 4 IP address or 4 interfaces, 2 for each T0. That's the a option for the uplink connection. For dynamic protocol point of view, you can use a static routing protocol, static routing. You can use OSPF. You can use BGP. So that means for OSPF, you just created adjacency among these 3, among these 3 adjacents, yeah, for each subnet. That's it. That's for the logical topology. So if you already knew this logical topology, then we have our IP planning. So you have to make a list or make a table for in detail for every IP addresses or subnet or VLAN ID you're gonna use. So very important for you to prepare for this. And the subnet or host name, you can create your own table and including more columns. I just created my own for including 4 columns. One for subnet and host name. This is a management VLAN. So /2027, including the 32 IP address. And you need a gateway for this VLAN or for this subnet. And those are machine or host name or VM name for you to use. For example, there's a ESI compute, ESSI host, ESS1, ESS2, ESS3 for your compute cluster. This is IP address for each ESSI host. And this is the vCenter ESSI manager. If you have a 3, you should give 3 IP addresses, and edge 1, edge 2 management address. This is a management IP for each edge node, because if you want a telnet or SSH to your edge node, you need to have this management IP address. If you are having to install your VRNI or other solution, VMware solution, so you should take them into account. So consider this and assign a more IP address from your management subnet. Here is a VRNI proxy, and this tool is for RV load balancer for NSX ARB. If your POC includes RV load balancer testing item, so you should take into account those kind of load balancer related IP addresses, and you should have your gem box and the Active Directory and DNS and NTP for the vSphere environment. And this is a login site, VMware login site for log capturing, and also some of the tester machine. The second subnet for in this IP list is the TEP IP list. So this is for tunnel uses. Here I gave 32 IP addresses for tunnel uses. And also you have to have a left leg uplink or right leg uplink just associated with our previous diagram for a connection to the physical router. So here is 29 is net mask. So you just we commonly call uplink 1 as a left leg, uplink 2 as a right leg. And also you should consider your real production uses. For example, web segment and app segment, DB segment for your overlay production VMs. So those are the required IP addresses and the VLANs and also subnets. So some of them will be negotiated with your customer. So just be prepared ahead of time and give them more time to think about the whole arrangement. So let's talk about the NSX design itself. So there are a lot of aspects of NSX design. For example, when we be assigned a deployment task or just given a POC, we have to think about, is it a single for a single data center or is it a multi-data center? Is there any bare metal or just some of the extra security requests you have to think about? And more, for example, load balancer requests. Is there any RV related testing items for those kind of things you need to consider? Because for example, for a single data center, it's pretty easy for you to deploy. If you're a multi-data center, for example, 2 data centers, you have to consider. So you have to consider more, or just pick another solution for the appropriate uses. And another thing you want to consider is a physical network. Many times customers' network not as ideal as you thought. So just think about the real network and real resources that are given to you. So that's a physical resources and never a situation you have to encounter. Okay. So these three is the key, is the meat of our lesson. So, for example, we talked about from NSX point of view, we have our control plane, we have our a management plan. So being mixed into the manager VM. So we have to think about the connectivity or design of an NSX manager. So how you locate this manager into the single data center or into the multiple data center, especially for multiple data center design. This is a critical one of the aspects you have to think about. And another two is design for compute host or design for edge node and edge node cluster. This is a focal point for for today's lesson. And when we look at compute design of our compute system or compute transport node, here's some of the recommendation and kind of like optimal uses or a best practice for you guys to know. So if you can request some resources, so for 10 gig Ethernet NIC physical server or a physical server with 1040 gig network adapters are ideal for you to set up the whole NSX system. So this is recommendation for a customer and for if you're a partner for you to ask for. And for sure, if you are facing a greenfield project, it's pretty easy for you to install, for you to propose your design for the whole greenfield project. But sometimes or many times, customer just have, if there's a brownfield project or some of the old machine or existing physical machine you have to leverage, so that maybe that's the real design for the compute transport node. So you have to ask for a physical server with four 10 gig NICs. That'll be better for you to go ahead. Because if you are given a physical machine with two NICs, and these two NICs, for example, these two NICs are being used with a lot of uses or a lot of traffics. So a lot of traffic, existing traffic, or some of the uses, for example, vSAN traffic is already there. So you can just, you have to have a migration to adapt, kind of like to insert an NSX function or kernel into your existing infrastructure within your ESSI host or within your computing. So that So we say that if you have 4 NICs server, so P1, P2 has been used already. For example, has been vMotion or vSAN traffic or management traffic or some of the existing VM. Right here, VM1, VM2. So you can use the actual 2 ones, P3 or P4. You just the hook it up into the switch 1 and switch 2 for P3 P4 physical adapter, and you just install your NSX, just the compute whole preparation of your whole transport node. Please refer to the lab compute transport node I already reported in the previous video for how to install your compute transport node. So in the process or in this procedure, NSX just created a VDS with NSX and just assign a new uplink 1, uplink 2, and you just connected this uplink 2 logical concept, logical uplink 1, logical uplink 2 object to P3, P4 physical NIC. That's it. And you just connect your production or simulated virtual machine onto this new VDS. So simply put, you just created a brand new VDS for P3, P4, and for your new virtual machines and for the NSX functions to be used on this new VDS. So the existing VDS, because you don't have any touch on this, just leave it as it is. So just you pretty much lower the risk for you when you are on a brownfield project, or just you have some of the cutoff, because you don't need to have some of the migration. So for the network point of view and the summary request for the network team to configure the physical switches, you just we just need to have a trunk configuration. You just configure this port as a trunk. That's it. That's everything I request. Channel group for just aggregation, ACG as well, but other for channel is totally not needed and not recommended or suggested for NSX to use. So just only trunk function is requested. Okay. Let's move on to edge design. We talk about T0, Tier 1 function. We talk about LR, SR. When we locate SR onto edge node, we have to set up or install our edge node VM. So in turn, we have to think about the design of the edge node. Here we just give you some of the best practice for edge node VM design. Here's our edge node, right? Here's our management ESX host. within our management cluster, or is this a particular machine, ESS machine for our edge node? You can have another ESSI too for edge node 2. So you just skip this one, because normally we just put one edge node onto each ESSI host for the sake of HA or safety. So let's get into it. For each edge node, we have 4 unique fixed, because when you install this edge node OVA, this is if we talk about VM mode, form factor, we have to an OVM is imported into the SSI host. So for this edge node VM, we have 4 unique fixed, 4. We can configure, we can change it. For example, the orders for association, no, you can't do that. Here we have fixed VNICs. VNIC 1 only for management uses. So we can, when we configure edge node, we have to give a management IP for VNIC 1. For VNIC 2 and VNIC 3, they are used for overlay traffic, for TCP/IP tunnel, and also for uplink, edge node uplink. Here we have VLAN 200 for TCP/IP or Geneva tunnel or overlay traffic. We have 2 VLAN 300 and VLAN 400 for uplink 1 or uplink 2. So they are gonna use VNIC 2 and VNIC 3. And VNIC 4 for bridging function. If you have a bridge, logical bridge, just like a T0 or Tier 1, you have a bridge deployed into this edge node. So bridge will use VNIC 4 for bridging traffic. For example, how do we use bridging? Here's a case. Commonly, we use bridging for migration or just transit state. For example, we have a VLAN-based, VLAN back or VLAN-based subnet. There are several physical machines here on the existing VLAN back subnet, and we install NSX. We deploy NSX. Here we have overlay subnet. On this overlay, there are some of the new VM here. So we want this VM to communicate with the physical server on the VLAN-based subnet. So we have to connect this VLAN-based subnet or VLAN-based data link to this overlay or segment. So that's a bridging. We have put this bridging between this VLAN, this link and this subnet. So we just bridge a traditional VLAN to overlay subnet. That's a bridging. Okay. So when we take a close look at the VNIC 2 and VNIC 3, here we can see that there's two VLANs, VLAN 200, VLAN 300, right? So just that means that we prefer, so here on this link, on this association, or on this link, they only allow two VLANs, VLAN 200, VLAN 300. So VLAN 300 uplink 1 is preferred on this link over this link. But for VLAN 400 traffic, they are preferred on this link over this link. So that's, but when you look at the VLAN 200, it's low balance. The traffic will be low balance onto the uplink 1 and uplink 2. This is detail. So onward, we have our VDS, right? So on this VDS, we have newly created trunk 1 and trunk 2 per group. So you have to create trunk 1 and trunk 2 on vCenter and associate VNIC 2 to the trunk 1 and the VNIC 3 to the trunk 2, just like this drawing here. That's the connection. And onward, we have another association. We have to configure this port group teaming policy to pick up P1 as a primary physical port. So for this port group, trunk 2 port group, we prefer P2. So this is the teaming policy for this two port group configuration. So you can see the from very inside to the very outside, you can see there are a lot of layers for distribution of traffic. So we can manipulate those kind of distribution or associations within each layer. For example, by leveraging uplink profile, right? We talked about that. We can associate this these kind of things right here. So we can leverage port group teaming policy for association, like within this layer. So we have we have 3 or 4 layers here, out there for you to manipulate the traffic. So this is a little bit complex. So, but you know, this is theories, but we're gonna give you and guide you through the whole configuration via NSX UI. So I think you can get across thoroughly. So we talk about the preferences for the VLAN-based uplink. We talk about load balancing for VLAN 200 for tunnel traffic. How do we implement that? How do we get it done? So we're just using something we talked about called a named teaming policy, because if you look at this configuration, we have our load balanced teaming policy, which is default teaming policy for red traffic. We also add two policies for VLAN 300 or VLAN 400 for this own preferences. In this case, for VLAN 300, they have their preferences for uplink 1, which is this link, uplink 2 for this link. I think you got what I mean, just by using this kind of data structure to implement this connections distributions. Okay. So here we have another option for agenode design, which called a collapsed model. Collapsed model is just mix everything, put together everything into onto the one ESS host. So we call it collapsed model. We put production VM, or we can call it NSX controlled production VMs onto the NSS segment, right? Those are overlay traffic related to VM. So from this point, for this traffic, we have to have a tunnel. We have to have creating the tunnel with TCP/IP, right? TCP/IP. So here we have TCP/IP1, TCP/IP2 for redundancy. So for TCP/IP1, TCP/IP1 will be terminated on the VDS for production VMs, right? But when you look at edge node operation or edge nodes traffic, we have another pair of TP. So there are two types of tunnels we have to deal with. One is for compute VMs traffic. One is for edge nodes traffic. So here we have two more TCP/IP or TCP/IP for edge node traffic. But be careful, notice that they're on the separate VLAN. Because we have to separate the function, we have to separate the termination of two tunnels. So here, we request different VLAN ID. So you got it? That's a pretty detailed stuff. So you have to think about, you have to, for the sake of design or IPS planning, if you want to use collapsed model, you have to give two tunnel subnets. But this model is totally not recommended, because when you think about the traffic, it's just like a zigzag. For example, traffic from this virtual machine will go like this and goes to their T0 gateway, which is like this. So kind of like zigzag traffic. And you should calculate and work out the real traffic for your physical adapter capacity, for even the capability and capacity. You have to think about two factors. That's it. So I just give you an exception, starting to 3.1, that they can be on the subnet. So tunnel TCP/IP, 4 TCP/IPs, they can be on the same subnet. starting from NSX 3.1. But the edge TP needs to be set on the NSX segment. That means that VLAN you don't is no traditional VLAN ID is not allowed for you to use on for this situation. You have to create a new segment, NSX segment, for you to use for this purpose. For tunnel or TCP/IP uses. That's a little bit tricky. So let's say we're not this kind of model are not recommended. Another model for POC, if you're conducting a POC, you can use this just a little bit simple model or alternative model. So you have 4 NICs, right? And these 2 NICs are already been occupied for existing traffic, and P3, P4 is a new connection for NSX installation, and you just create as before, create a new brand VDS with NSX, a brand new VDS for NSX and for the new production VM. Just be careful, or please note that collapsed model only have one VDS, right? Only have one VDS for all the function. But here, you have to create a new one. So you have 2 VDS. That's a difference from the previous one, collapsed model. And then by using the previous or existing VDS, you just add your edge node onto existing VDS. So on this VDS, you just create a new trunk port group. Those kind of things is pretty easy and with lowest risk. And just import your edge node. You just install your edge node onto this existing VDS. That's pretty safer for you to start your POC. And especially so your customer don't have a lot of resources, physical resources for you for your POC. That's an alternative model. Okay, so that's everything for the for design of compute host and the design of your edge node. But this is pretty critical for the whole NSX system. So you have to prepare yourself well. You have to make a list. You have to make an IP table ahead of time and just discuss those kind of things with your customers, and in next video, I'm gonna give you real live demo and how to create your edge node, how to connect your uplink to the external routers, and also in the next video, so I'm gonna give you and just gonna talk about OSPF, BGP, so like some of the detailed stuff. So that's it. Hope you enjoy it, and I'll leave the design reference guide URL in the comments below. And if you guys have some of the comments and questions, just leave it there, and I'll hit it up, and I'll give you the answer as quickly as I could. And thank you so much for watching, and see you soon in the next lesson.